Good morning, students. In the previous lecture, we have learned about the second law of motion and also the momentum. So, today we are going to learn our next topic, that is mathematical formulation of second law of motion. For that, we will first let's state it the second law mathematically. So, the Newton's second law of motion is the rate of change of momentum of a body is directly proportional to the applied unbalanced force in the direction of the force. So, this is the Newton's second law of motion. Now, let us see further that we know the formula of momentum, which is given by mass into velocity, that we had already learned in our previous lecture, that is P into M into V. Now suppose there is an moving object of mass M that is moving along the straight line with the initial velocity u. After the time interval t, the object accelerates and moves with the velocity v by the constant application of the force. By this, so the initial momentum is represented by P1, that is P1 is equals to mass into initial velocity. So the mass is represented by m and initial velocity is represented by u, that is P1 is equals to mu, as you can see in the image. In the second case, the final momentum is represented by the P2, that is mass into final velocity. So the mass is represented by m and final velocity is represented by v. Now the change in momentum is given by P2 minus P1, that is the final momentum equals to initial momentum, which is given as P2 minus P1 is equals to, or we can say proportional to, mv minus mu. And now this mv minus mv is equals to m taken as common, so inside the bracket, so it will become v minus u. So the rate of change of momentum is given by m into v minus u upon t. Now, according to the second law of motion, as you can see in the image, the applied force is directly proportional to the rate of change of the momentum. So, from the above equation, we can see that the rate of change of momentum is directly proportional to the m. That is, force is proportional to m v minus u upon time interval. Now, let's remove the proportionality between the two and introduce the constant k. So, the equation modifies to the force is equals to km into v minus u upon t. Now, F is equals to k multiplied by m. So, it is multiplied by the bracket. Inside the bracket, there is v minus u. So, the whole equation is divided by t. Now, we know that acceleration is given by the rate of change of velocity. So, the acceleration is represented by a, and the rate of change of velocity is represented by v minus u upon t. So using this equation and arrange the equation number 1, that is, instead of v minus u in equation number 1, substitute with the a. So the equation modifies to the f is equals to km multiplied by the acceleration. So the k is the constant of proportionality and the value of k is equals to 1. So from this mathematical formulation of second law of motion, what we get, F is equals to k into m into a. Now what is the unit of force? Now let us see the unit of force. From the above formula, we saw that F is equals to km into a, where k is given to us is 1. So I am putting the value of k is 1. So F becomes equals to m into mass into acceleration. Now the unit of mass given to us is kg, and that unit of acceleration is meter per second square. So from this we can say that the unit of force is now becomes kg into meter per second square, and this whole term is represented by the 1 Newton. So the SI unit of force is 1 Newton, and it is represented by capital N. Now let us define what is the 1 Newton, and in that case 1 Newton is given by 1 kg into 1 meter per second square, as you can see in the image. So it is the amount of force that produces an acceleration of 1 meter per second square in an object of 1 kg mass. So from this we can conclude, or we can get the 1 Newton, that is unit of force. Now let us see how this mathematical expression of Newton's second law is helpful to calculate Newton's first law. As we know that F is given by mass into acceleration, and we also know that acceleration is given by v minus u upon t. So we also substitute this value of in an equation, F is equal to mass into acceleration. So we will get the expression as F is equals to m, and in bracket v minus u upon t. On rearranging this equation, T is multiplied by the force, that is Ft is equals to m, and in bracket v minus u upon. So from the above equation we put F is equals to 0. So from it we get v is equals to u. Thus we can say so that when no force is applied, then the object will continue moving irrespective of whatever time is taken. That whatever will be the initial velocity of the object, it will become the final velocity of the object. Now here is the end of the mathematical formulation of second law of motion. Now let me teach you some simple problems. So first is, what force is required to produce an acceleration of 40 meter per second square in a cricket ball of mass 0.5 kg? So let me highlight the given data of the problem. So we are given three variables to find the force. So the value of acceleration is A is 40 meter per second square and mass m is 0.5 kg. Now, according to Newton's second law of motion, F is equals to m into A, where F is force and m is mass and A is the acceleration. Thus, F is equal to 0.5 kg into 40 meter per second square. Hence, the result we get is 20 kg per meter square. Hence, we know that 1 kg meter per second square is equals to 1 Newton. Hence, F is equals to 20 Newton. This means if we exert the force F that is equals to 20 Newton on a cricket ball of mass 0.5 kg. So this 20 Newton force will produce 40 meter per second square acceleration in it. Now come to the second problem. That is find acceleration produced in engine that is force of 3600 Newton in a car of mass 600 kg. So in this numerical we have to find an acceleration. In this the force is given at 3600 Newton and that of mass is 600 kg. So according to the Newton's second law of motion, F is equals to ma. We need to find the acceleration A of the car. So shift this m from the right hand side to the left hand side. So A is equals to F upon m. Now plug in this value in this equation as A is equals to 3600 Newton upon 600 kilogram. So as a result we get 6 meter per second square acceleration. Hence 3600 Newton will produce acceleration of 6 meter per second square in a mass of 600 kg. Now come to the third problem. That is calculate the force required to stop a car of mass 1400 kg in 2 seconds if it is moving with velocity of 10 meter per second. Now I will highlight the given data first. So calculate the force F, and secondly to stop a car means that final velocity Vf of the car is 0. Thirdly, the mass m is equals to 1400 kg and time is 2 seconds and it is moving with velocity. So its initial velocity is 10 meter per second. So there are 5 variables in this problem and we have to find force to stop a moving car. So according to Newton's law of second law of motion, F is equals to force into mass. So here the mass of the car is 1400 kg. And what about the acceleration of this car? So to find the acceleration of this car, we had given the initial velocity Vi and final velocity Vf and time t of the car. So the acceleration of this car is equals to Vf minus Vi upon time. So now I will put this value of acceleration in the Newton's second law. Thus F is equals to m into Vf minus Vi upon T. Now hence I will plug in all this value in this equation. So F is equals to mass m, and so m is equals to 1400 kg into the final velocity, which is 0 meter per second, and the initial velocity, which is 10 meter per second upon time. Now which is, so the value of force we get is minus 7000 Newton. Hence, the negative sign shows that minus 7000 Newton is a retarding force. It means this force will stop the car. Now, last problem is two objects of mass 5 kg and 8 kg are at rest. And F1, F2 are the forces applied on both respectively. So, if the speed of both the objects after 10 seconds become 10 meter per second and 20 meter per second, then find the value of the F1 minus F2. So, now again I will highlight the given data. Firstly, there is a mass 2. So, we given there are two objects as mass m1, that is of 5 kg, and second as mass 2, that is of 8 kg, and both these objects are at rest. So both the initial speed or initial velocity Vi is equals to 0, and Vi2 is also 0. On the first object, the force applied is F1, and the second object is there. On that, the force is applied as F2 respectively. And then the time is given 10 seconds, and final velocity of Vf1 of object 1 is equals to 10 meter per second, and second object final velocity, that is Vf2, which is 20 meter per second. And then we have to find the value of F2 minus F1. So firstly, we know that force is equals to mass into acceleration. So we have given the masses, but acceleration is not given. So first of all, we will find the value of acceleration. So we have given the second objects. So both have different forces, different masses, and both have different velocities also. So from this we can say that both objects' acceleration will also be different. So we have already learned the equation of the motion. So according to the second law of the motion, that is Vfi is equals to initial velocity plus acceleration into time, that you can see in the image. So the value of Vf is 10, then Vi is 0, and acceleration we have to find it, and the time we are given is 10 seconds. So the acceleration of first object is 1 meter per second square. According to this formula, we will find the acceleration of the second object. So the second equation will be Vf2 is equals to initial velocity of Vi2 plus acceleration into time. So the value of V2 is 20 meter per second. Then Vi2 is 0 because it is at rest. So we have to find the acceleration, and time is also same, that is 10 seconds. So then we have to solve this problem. From this we get the acceleration will be 2 meter per second square. Now students, we have to find F2 minus F1. For that we have to first find F1 and F2. So how the F1 will come? So it will comes from this equation, that is F1 is equals to mass into acceleration. So F1 is the first object of mass, that is of 5 kg, and acceleration is 1. So we will get F1 is equals to 5 Newton. Now in the same way we will calculate the value of F2. So the formula is again mass into acceleration. Now F2 of the second object of mass is 8 kg and its acceleration is 2. So we will get F2 will be 16 Newton. So now we have got the both values F1 and F2. So from the question it is said that we have to find the value of F1 minus F2. So now we have got this value. So we'll now put this value. So F1 is 5 Newton and F2 is 16 Newton. So we will put this and we will minus the equation. So the value of F1 minus F2 we will get is minus 11 Newton. Thank you.